Rigor mortis, the sliding filament theory by Rylann and Sammie.
Looking at a structure of a skeletal muscle, which is striated muscle that acts by involuntary movement, we have our muscle fiber, sarcoplasmic reticulum, myofibril, sarcomere, myosin, thick filaments with intertwined tails and heads that bind to actin. Actin, thick filaments of intertwined actin monomers with myosin head binding sites.
Now let's zoom in on the myofibril. Sarcomeres are the functional unit of a striated muscle. Once they shorten from Z to Z, the skeletal muscle contracts. This causes the myosin and the actin to intertwine.
All of the things needed for contraction are actin, found in the myofibril, myosin, also found in the myofibril, ATP, which binds to myosin to provide energy for muscle contraction, and then calcium ions, which allows tropomyosin to move away from the active sites, but we'll talk more about this later.
But where does ATP come into play? Think of your muscle fiber as a very sturdy piece of rope. ATP is broken down by a very crucial cell organ, the mitochondria. Let's zoom in.
Looking at the neuromuscular junction, which is the synaptic cleft between the muscle fiber and the motor neuron, once an action potential runs down the motor neuron, the axon terminal releases acetylcholine, which is a neurotransmitter, into the neuromuscular junction, signaling the muscle to contract.
Taking a closer look at strands of troponin complex. We have our tropomyosin, which blocks myosin binding sites. Actin, which will bind to the myosin after contraction, and myosin binding sites, which are covered by tropomyosin. And then troponin, which is a protein attached to the tropomyosin.
But what happens when calcium is present? Now looking at contracted strands of troponin complex, notice that the tropomyosin is not covering the myosin binding sites any longer. But remember, in order for tropomyosin to move away, calcium ions must be present.
So how does this relate to rigor mortis? Rigor mortis is the stiffening of the body several hours after death. When you die, your muscles continue to contract from Z disc to Z disc.
Your muscles begin to lack oxygen because you don't breathe after you're dead. Therefore, your breathing and circulation comes to a halt. Therefore, ATP can no longer be produced. Your muscles are unable to release contraction, and so all muscles remain tense, which causes rigor mortis. Thanks for watching!